right, so in the first problem there, it's already done for us. We already have that dot plot. We're just going to talk about why would we use a dot plot. What makes sense about that dot plot? What are some things that we found last chapter that are going to be really easy to find? What would be really easy to find using that dot plot? Our maximum and our minimum. Good. What is our maximum? Yep. Yeah. What number is our maximum? Sorry. 40. Yep. Our max is 40. What's our minimum? 25. So what's really important about a number plot or a dot plot is that when we look at that number line, we have to decide what each tick mark is. It looks like it's counting by twos because it says 26, 28, 30. But there's a tick mark in between each of those numbers. So how much is each tick mark? Just one. So what is our minimum? 25. So it'd be really easy to find our range. So anyone remember, how do we find range? Good, maximum minus the minimum. So 40 minus 25. 15. So our range is 15. It should also be pretty quick to find our mode. How am I going to tell what is my mode? Yeah, which one ever has the most points? It's really nice on a dot plot if the people who are making it, they made all this level 1 row the same height. So we can really just see which one has the most height. 32 and 38. So this time we have two modes, 32 and 38. They both have 2. As far as mean goes, in this case, our mean would definitely just be easiest just to use the list of numbers. We don't need the mean to be ordered least to greatest. We just add them all up, divide by how many there are. What's something that's nice to have least to greatest, though? Median. So let's find that median. This is where I'm going to use my highlighter. I'm just going to highlight the dots as I go high, low, high, low. Okay, so this 25 is the low. That's going to go with this 40. This 28 goes with one of the 38s, not both, but just one. Doesn't matter which one because they're both 38. Okay, this 30 would go with the 38. This 31 would go with the 32. So what is our median? 32. So for mode and median, max, minimum, range, dot plots are pretty easy to see those. Makes it a little bit faster, a little bit quicker. The big thing with dot plots is it works really well if we can count by ones. As soon as we have to count by like 5s or 20s or 100s, we'd have to really estimate about where those dots go, and it kind of loses its purpose. All right, so let's make a dot plot. We're going to do it with the second one, hits in a round of hacky sack. So in our hits in a round of hacky sack, we want to figure out our minimum and our maximum because the first thing we have to do is make the number line. Maximum is 12. You're right, once we get there. So minimum is 3, maximum is 12. We have to think, what are we going to count by to go from 3 to 12? Should we count by 1s, 2s, 10s, 100s? Probably 1s. From 3 to 12 is not that bad. That's only going to be 10 tick marks? 9 tick marks? Okay. If once you get past 15, if it's a spread of 15, then you might want to start counting by 2s. So we're going to create that number line. I have a weird hole in the middle of mine. Some of you might also have that weird hole. Try and just get it so it's not there. Sorry, I was waiting for an opportune time. All right, and 4, 5, 6, 7, 8, 9, 10, 11, 12. If you have yours spread out enough, you can label every tick mark, or you can kind of do like what they did up here where they labeled every other tick mark. It's still counted by ones, but they just did like 3, 4, 5, 6, 7. If it's not too much, if you have yours spread out, you can just label every one though. Okay, and then what's nice about our dot plot is we don't really have to worry about putting things in order. We can just go and start at the beginning and just work our way through to the end. Okay, so we have an 11. So I'm going to start with my dot at 11. 9. 6. Hi. It is. Thank you. There's a little switcheroo there.
Yeah, there's a little, it's like a mixer.
It's always fun. 12. Okay, now I see another 6. So what am I going to do? Good. Add another one right on top of it. We don't necessarily make the dots bigger. All the dots are the same size. We just stack them. Okay, and then I have another 6. So there should be 3 dots there. Another 12. And a 4. Now, because we created this one, it's a little bit easier to see. Were there any 10s? No. No. How do we know that there was no 10s? There's no 10s on the list. How about on the number line? How can I tell that there was no 10s? There's no dots, but the 10 is still there. So doesn't that mean there has to be 10? No. Okay, good. The number line is separate from the dots. The dots actually mean the data points. The number line is just there for us to see how that is spread. All right, we're going to move on to stem and leaf plots. I see a couple of you are already doing your maximum, minimum, crushing it, but we already did that once. We're not going to do it again. All right, so stem and leaf plot. Okay, so the way a stem and leaf plot looks is it's always going to have a table with 2 parts. The first part is the stem, and the second part is the leaf. Something else that a stem and leaf plot always has to have is a key to tell us how to read it. Okay, that key is going to be really important because sometimes it's like 32, 34, but sometimes it's like 300,400. Okay, so a stem and leaf plot is a way to show data using 2 place values. So sometimes we use like the tens place and then the ones place, or we use hundreds and tens, or thousands and hundreds, but we're using 2 of those place values. Okay, and what's always important is that all numbers listed are paired together. So every leaf, every number in the leaf goes with a stem. Those stem, we have that little line, and a leaf. All right, I'm going to pass out a piece of paper. I'm going to personally just glue it on the next page because I don't have enough space. If you wanted to, you could maybe cut off these top 2 and glue it in if you have enough space for that, but I don't have enough. So I'm just gluing this on the next page. Okay. So I would just glue it on the next page personally, but if you have enough space, you can figure out how to get it in there. You go for it, but kind of.
I'm going to school.
So I would just glue this in on the next page. What I'm going to do, if you want to cut it apart and figure it out, you do you, but that sounds complicated to me. I gotta make it so complicated. She's being an Avril Lavigne, you know. Heard she's on a comeback. No? You guys know who Avril Lavigne is? She's coming back. Gonna be a rock star again.
Have you heard the conspiracy that she got switched out by
Yeah.
a body double?
Yeah,
That's interesting.
it's very interesting. Yeah, of course. I fell into that rabbit hole one night.
Like, that's interesting.
Very interesting. Makes some compelling evidence. But the person who like originally said it came out and was like, I just made that up.
Yeah.
Like, so it's interesting because it like weirdly makes sense. But the person who came up with it is like, no, I just made that up.
I get to see her live in October.
What?
I'm going to
Bring me.
No, I'm going to the music. I'm going to the music festival
In LA?
in Vegas.
Yeah, that's what I meant. Oh man. There's so many good places there. So many good things that are happening there. I wanted to go. Alright, here we go. So 7 leaf plots. In this first one, we have our test scores. And how are we reading those test scores? Good. Stem is the tens place. And the leaf is the ones place. So here we really have what is 3, 1. 31. And then 3, 4. 34. Then 37, 39. Good. Okay, so that one's mainly there just for us to see how it works all together. Let's just highlight 1 together. So let's do 49. Where do you see 49 in your stem and leaf plot? The 4 and the 9. So that 49 got split apart. The 4 goes underneath the stem. And then the 9 got put underneath the leaf. So 49. Okay, big thing about a stem and leaf plot is it's organized least to greatest. So notice our stem goes 3, 4, 5, 6. But then for each row of leaves, it goes in order. 1, 4, 7, 9. 2, 9. 2, 3, 5, 5. Okay? Alright, so let's look at this next one. This one is the one that we're actually going to do some data with. This one we're talking about boiling points with like different liquids. At what degree Celsius do they start to boil? Okay, and it gives us our key down here. 1, 5 means 1,500. So what would like 2, 6 mean? Good. Okay, when we see that line, that's telling us it's the thousands place. So 2,600. Okay. And again, this is really nice just for the same things that a dot plot is nice for. Okay, it kind of condenses it. All right, what is our maximum or minimum? When we look at our minimum, we're going to start at the very top in our stem. And what is our smallest leaf in that stem? 1. What does it mean for 0, 1? Yeah, just 100. This is the thousands place. It's saying that we don't have 1,000. We're not at 1,000. It's just 100. What is our maximum? Good, 4,100. So for our range, we would subtract 4,100 minus 100 would be 4,000. Okay, the next thing that's really nice to work with is our mean, or not our mean. Our mean, this would be a pain. Our mean, we would want just a list of numbers because we'd have to think about this every time. 100, 100, 100. Then we have to like rethink of this. 2,200. Gets to be a lot. So we're going to think about our mode and our median for this one. So for a mode, I want to look at just each row of the stems. So does this 9 represent the same thing as these 9s? No. So it's really important that when we look at this, these 9s mean 2,900. So there's two 2,900s. This 9 is just a 900, so they're not the same. So which number is repeated the most in a single row? Yeah, this 100s, right? There's 4 100s. So our mode is 100. It happens 4 times, but the number is 100. Okay? Now, similar to our dot plot, we see that this 3, there's nothing there. Does that mean that was supposed to be a 3,000? If we wanted a 3,000, it had to be, what, 3 and then 0. But there's nothing there. What does that tell us? There's just no 3,000s. No 3,000s at all. All right, so for our median, this is where I'm going to grab my highlighter again. I was going to switch colors this time just for funsies. Now, our median, we have to be really careful because we have to think what's high and low. So I'm going to start with that 100 is the lowest. And what goes with that 100? The 4,100. Maybe I should have stuck with pink. It's kind of hard to see. Okay, then it's going to go with that 100 again. What's the maximum that would go with that one? 2,900, the very last one. Okay, then we have the 100 again, would go with the 9. Good, would go with the 2,600. $2,400, good. 300 goes with 2,400. We have another 300, would go with 2,200. I think you got one ahead of us. But yeah, you're right. 400 would go with the 800. So we actually have 2 numbers left in the middle. So what does that 9 represent? 900 plus, what's our other number? 1,500 or 1,500. And we're going to divide that by 2 when we add. Remember, when we have those 2 numbers in the middle, we add, divide by 2. What is it? Shania, can you open your calculator for us? Yeah. 900 plus 1,500. And then divide by 2, yep. Duh. Try that one more time. So do 900 plus 1,500. On your iPhone, you have to hit equals before you do divide by 2. So 900 plus 1,500 equals, and then divide by 2. 1,200. All right, we're going to do one example where we create a stem and leaf plot. And then we are going to have the rest of the time for practice. You'll get a little bit of time for practice tomorrow, too, if you don't finish your practice today. All right, so at this problem here, what are we talking about? What does life expectancy mean? The average amount of people that are going to live. This one says Luxembourg, if you're really, really curious about the country. Do we need to worry about country names when we make a stem and leaf plot? No, so that's kind of another downfall of stem and leaf plots, is that if I wanted to know where did this 72 come from, we're not going to know that it was attached to that country. Anyone know how to pronounce that country? Vanuatu? Vanuatu? I don't know. Vanuatu? I don't know. All right, so we're going to create our stem and leaf. With these problems, would it make sense to break it up into like tens and ones, hundreds and tens, thousands and hundreds? What do our numbers look like? How could we break them apart? Tens and ones. Good. So this is already organized for us, which is really nice. So we can just kind of work our way through. But the big thing is that we can only use two numbers. So this first one says 47.5. Okay. So we have to round it to the nearest whole number because we just want a tens and a ones. We don't want the decimal point. So 47.5, are we going to round that to 47? Stay at 47 or round up to 48? Round up to 48. So I'm going to just do a little arrow there to remind us we rounded up to 48. So it's going to go 4 for the stem. And then my leaf would be 8, 48. Okay, next I have 60, but I can't just jump to 60. What do I need here first? A 5. I need the 50s to be represented even if we have no 50s. So I'm going to jump to our 6 for 60, and we just have 60. So 6, 0. Okay, 61.5 is going to round to 62. So where am I going to put that 2? Right next to the 0. I don't have to make a new stem. It comes from the 6. So it's 62. Right. 69. So I just put another 9 there. How come we don't want a decimal? Why would that be confusing? Instead of just doing 62, why can't I do 6 and then a 15? Yeah, because then we wouldn't know which numbers go together, which numbers are separate. It'd be a lot. So we just want those two. Okay, now comes the 70s. There's a lot of 70s. So we have 72. Good. When it's a 0.2, we stay at the number we were at. So 73.
And then you do it again. It stays at 74.
74. What about 74.5? That would round up to a 5. 74.7? A 75. So I'm still in my row of 70s. I haven't moved from that. And then this one's actually 75. 77. And that's all for the 70s. So we're going to move on to 80s. Good. 80 has to have a 0. 81. Okay, so this 81.7 is where we're at. The 0.7 tells us to round up. So 82 and then an 82. There's one thing we're missing from our stem and leaf plot. We need a key. We don't need a 9. We would need a 9 if there was going to be a 10. But 82 is our highest, so we can just stop there. But we do need a key. So we're going to just pick one of the numbers and show that what does it mean. Okay, so we could just do the first one. So 4, and then that line 8 represents 48. Now, what's interesting about this is what does it look like is our mode? Yeah, those 5s, and that's 75. But if you look back at our data, how many 75s were there? There was actually only one 75, but when we rounded, it gave us a new mode. So when we do stem and leaf plots, it's really nice because it organizes it for us. It condenses it. We don't have to write out all the numbers. But if we want to be really exact with our data, stem and leaf plots is maybe not the best choice. All right. So you have a practice to do. It is